Hello again. We're up to 6C. Today's topic, the converse of Pythagoras' theorem. Okay, what is the converse of Pythagoras' theorem? Well, the actual theorem, the one we've been using so far, is that formula a squared b squared equals c squared. So what it really says is, for every right triangle, right? If you start with a right triangle, then this will happen. Leg squared plus leg squared is equal to hypotenuse squared. That's what the theorem says. The converse is if we say it in reverse. If you ever come across a triangle, right? Any triangle, you don't know if it's a right triangle, and you try and do this, right? And it comes out to be true. You take two sides, square them, add them, and they equal to the square of the third side. If that comes out to be true, then you can say, aha, that is a right triangle. Do you see the difference there? Here we start with a right triangle. We know it's a right triangle. And we're missing a side, so we know this has to work. Here, we're not missing a side. We have all three sides. We just don't know if it's a right triangle. So we put those numbers in here and check it. So this answers a yes or no question. Is it a right triangle, yes or no? Well, it is yes if this happens. So, two quick examples, and then we'll talk more about it tomorrow. So this is going to be very short notes. Okay, first example. Here I have a triangle. I don't know if it's a right triangle, right? I have all three sides. So the question is it a right triangle, yes or no? Well, if it is a right triangle, then 3 squared plus 4 squared should equal 5 squared if it's a right triangle. So let's check it. 3 squared plus 4 squared equals 5 squared. Now, before we go on, notice where I put the numbers. Obviously, the only chance this triangle has of being a right triangle is if we make the big number, the long side, the big number, if we make that the hypotenuse. So the other two sides would have to be legs. Okay, so does it work? Well, this is 9, this is 16, hold on. This is 9, this is 16, and this is 25. Is 9 plus 16 25? Yes. So we are dealing with a right triangle here. I did not know this was a right triangle. I checked using the converse of Pythagoras' theorem, and it was true. It is a right triangle. Let's do another example, and that'll be it. Here's a triangle. I don't know if it's a right triangle. It looks like a right triangle, but we can't be sure. Okay, so the way we check is we plug in the numbers into Pythagoras' theorem. So the only chance for this to be a right triangle is if this big number is the hypotenuse. So the 16 squared is going to go on the right. So the question is this true? Let's see. This is 121, this is 144, this is 256. Is 121 plus 144 256? No. No, it's not. So we say that this triangle is not a right triangle because it doesn't obey Pythagoras' law, Pythagoras' rule. Okay, we checked. Okay, now keep in mind, try to understand the difference between what we did before and what's going on here. Here, we have the three sides. We're not looking for a side. The only time we can look for a missing side is if we have a right triangle. We start with a right triangle. That's what we said in the beginning. If you start with a right triangle, then you can use this to find the missing side. But today what we did is we didn't start with a right triangle. We started with a right triangle, some right triangle, and we're trying to see if this works. If this works, then we can say, yes, it is a right triangle. That's what we did today. So a quick flash of today's notes, which are very fast, and then the bottom. Okay, so we'll talk more about this tomorrow and see more examples before we get into the assignment. Okay, that's it for this one, a very short one. All right, see you tomorrow. Bye-bye.